With all the gadgets we have now, it's like it almost makes it obsolete. You know, I used to do a lot of traveling. Yeah. When you have a Zoom and everything else, it's just.
Yeah, I mean, you're doing those wonderful programs.
And plus, you need the graphics that you can.
Yeah, because he's not using the mic. So
I'm getting older, and I don't like.
No, don't say that.
I mean, real old.
if he would have started 10 years ago when I asked him
Bones
to.
are creaking, stuff like that.
You still play tennis?
Almost $3 million.
I got a hip problem.
I got a shoulder problem.
And that's what I mean. I can't play tennis. I don't even in my own neighborhood. Let alone going out. Reach that point sometime in your life.
It's like we have something to give him. You know, our suffering. That's what we get older.
I've got 6 kids to live with.
How many you got at home still?
6.
All six? You got how many total?
11. So even one by one, I have 6.
You brought a couple of your boys with you a couple of years ago.
Yeah. He's now 16.
Oh,
Based out in Texas.
In our travels,
Played a lot of music, teaching somewhere. And then I've got, so he's 16, I've got another girl that just started college. She's 18. And I've got a 14-year-old, a 12-year-old, and a 10-year-old girls. They're easy. So we got our hands full.
yeah. Yeah.
But it's a lot of
I
fun.
was surprised to see your wife there with you. That's great.
I have to discuss with my guests privately. Okay, well, as,
He's the boss.
okay, questions and answers.
All right, so let me tell you what happened. I went fast enough through this, and I didn't even know it at the time, but I went fast enough through it that I covered all 4 topics that we were supposed to do today. And as you can see, well, you can see, yeah, topic 5 was going to be our next topic, but that's for tomorrow. And this is the last science topic that we will have tomorrow. And I think this is probably the best one because it's the most exciting. And we'll see all the new discoveries in the universe that we have gathered in the last 50 years or so that basically put the stamp on it. You know, this is done and over with. We've seen all the evidence, and it all points to a geocentric universe, okay? So we'll see that tomorrow. And then we're going to cover the topics of Scripture, the fathers, the tradition, and especially the church, dealing with how the church has dealt with this issue from the time that the 2 popes had condemned Galileo in the 1600s, all the way to Pope John Paul II in his 1992 speech, basically saying that Galileo was right and Church was wrong, okay? And so we'll deal with that. And then I'm going to show you a preview of my new movie called How the World Was Made. It covers all 7 days of creation, and we're just going to see the first 2 days. And that's exactly 50 minutes. So that
Through this?
through that, yeah. Yeah, unless you have something better. But we'll look at that, and that'll be the end of the show. So I figured if there's any lingering questions about all this deep scientific stuff that we have covered so far, I give you the opportunity to ask your questions, and as soon as the questions are done, we can leave. Okay? Yes, sir, in the back.
What would you say to someone who would say that this notion of ether is your inference to support your cosmology, just like dark matter and dark energy are the inference of the Big Bang cosmology?
We say the question is, how would I explain the fact that our use of ether in the geocentric model is not any different than the use of dark matter or dark energy in the Big Bang model? And if you don't know what they are, let me explain that. In the Big Bang model, they don't have enough energy for the so-called expanding universe to make it expand. Because if you're expanding radially, that means you're accelerating. If you're accelerating, that means you need energy. And you need a certain amount of energy. Not just any energy will do. Okay? So they can't use the ether, by the way, because that has way too much energy. It has over 120 to the 10th power, 10 to the 120th power. Too much energy for them. Okay? They can't use that. So what do you use? Well, you have to use something, otherwise your universe isn't going to expand. And so what they do is they invent it. It's called dark energy. They don't know where it comes from, how it got there, what the form of it is. They can't tell you a thing about it because they've never found it. All they know is they have to have it in order to make their Big Bang universe work. Okay? Okay, now dark matter, they need to get some of this energy from dark matter, so they'll throw in the dark matter. But they don't throw it in for that very reason that they throw in the dark energy. They throw in the dark matter because they have a problem with galaxies. The galaxies out there, all of them that are spinning, spin 10 times too fast for Newton's laws of motion. You know, remember the F equals ma I told you about? Okay? If you use that, the galaxies should be spinning 10 times slower than they are. But they're spinning 10 times faster than F equals ma will allow. So what do? Well, you can't increase the F, you can't increase the A, because it's already increased for you, so you have to increase the M. F equals ma, you have to increase the M. And you can tell how much you have to increase it by. And that's what they call dark matter. They haven't found any dark matter. They couldn't tell you what it is, where it's come from, what even to look for. All they know is it has to be there in order to make these galaxies work. Okay? That's dark matter. And then the remaining dark matter that's there, that's not exactly in the galaxies, that's just in the universe, well, we'll use the energy from that to help us keep this universe expanding. Okay? So to talk about a band-aid cosmology, this is it. They don't tell you that. They just make you think that dark matter actually exists and dark energy exists. And who are you to say anything different? Nothing. Nope. You're a nobody. Okay? Yeah.
And to further
I still haven't answered this question yet, so I have to get back to it. Go ahead.
that's,
What?
I was going to say, there's got to be something between the Earth and the moon or the star or the sun, because if nothing's there, then we're all right up against each other.
Yeah.
There's no vacuum out there.
Yeah.
There's something, we call it ether, we can call it space.
Yeah.
But proponents and opponents of geocentrism or heliocentrism all agree that we have something there.
Yeah.
Ether is just the word for it.
It's just a word.
We call it space too.
There are about 12 different terms they use
Give us some.
for the substance. 0-point energy is one.
0-point energy?
energy, yeah. Maximons is another. What else? Huh?
Wouldn't it be the medium that matter and energy exists in?
Yeah, but what's the medium made of? That's basically what you want to get down to. What's the medium made
You
of?
said ether.
Yeah, but what's ether? So you just keep going back one step, but you don't answer the question.
So
So,
we call it the space-time fabric?
yeah, you can call it space-time vacuum, you know,
That's what Einstein called it.
yeah. But see, he didn't explain what it is though.
I just said that it was there.
Yeah,
That
it was there.
the medium that we used.
Just the medium, yeah. So we're trying to get to the point, why is ether an essential medium? Okay, well, Einstein himself said, if you don't have ether, you don't have any mechanism to make light travel. You don't have any measurements for time and space. You don't have any measurements for anything, because there's nothing there to measure it with, okay? So that's why he went back to the ether, because he needed a measurement scale. But he couldn't tell you what the ether was. He couldn't tell you what's bending when he said gravity bends space-time. He doesn't know what that space-time entity is out there. He just says it bends. Well, we know that if it bends, it has to be something, correct? Well, we're at a loss for him to tell us what it is. But at least he went as far as saying that it's ether. So, okay, we'll accept that, all right? Now, it's not that the geocentric system needs ether. We can work without ether. We just find that it's better to have an ether for all the reasons I just said. Now you have a light medium, now you have a gravity medium, now you have a magnetism medium, now you have a neutrino medium, you know, I mean, the medium answers all those puzzling questions we had. It's how do you get from one place to the other? Now Newton had this problem, remember? I said he believed in instantaneous gravity, but he had no mechanism for it, okay? And this has always been referred to as the action at a distance problem. You have an action, but you have this vast distance, so how do you join the two? And nobody could do it. Newton couldn't do it, Mach couldn't do it, Einstein couldn't do it. And that's why Einstein afterwards rejected Mach, because he couldn't explain how his relative universe, wherein the universe is going around the Earth, could communicate or relativize itself to be the Earth rotating in a fixed universe. How do you connect those two? In other words, how can you make the gravity travel fast enough from the edge of the universe to the Earth if you don't have a mechanism for it? So in that sense, he dropped Mach. Mach's thing was just dealing in principle. He knew, relatively speaking, you had to equate a fixed universe and a rotating Earth with a rotating universe and a fixed Earth. He knew that instinctively, and everybody accepted that. But there was never a mechanism how you join the rim of the universe with the Earth that's in the center, okay? And he didn't believe in ether, because he said he didn't believe in anything that was not empirically verified, okay? Okay? But now, we've come a long way since Mach. Now we've come to quantum mechanics. And in quantum mechanics, the ether was reborn. Okay? Now I have a quote that I don't have in this section, but I have a quote from a Nobel laureate. His name is Robert Laughlin. It's in my books. And he's talking about Einstein, and he says, you know, Einstein started out with taking the ether away from us. And then he came back and he gave it back to us. Okay, so he points that out first, and then he says, and you know what? This is exactly what quantum mechanics is teaching. That it's not empty space. Or at least we can say this, that what we believe is a vacuum to our senses is not really a vacuum, it is actually a substance. And it's a very discrete substance, such that if we put some of these particles in a cyclotron, we see them break apart, we see the same thing happening in space. If we hit it hard enough, we see these particles fly out. Okay? Go ahead.
A quick follow-up. I thought in your book you said the stars don't have to move at these tremendous speeds because it's the ether moving, and they're in the ether. So is that kind of important for the geocentrism model?
Well, it helps for people to visualize what's happening. Because they invariably think about, oh, you mean the stars by themselves are traveling at superluminal speeds? You know, how can that be? So I help them along by saying, well, it's not really the stars, it's the whole universe that's moving, and the stars are moving with it. But even saying that, the fact remains that whether it's the stars or the universe, they're moving at superluminal speeds. Now, why can I say this? Because Uncle Albert said I could.
Who said you could?
Uncle Albert.
Mm-hmm.
So if you can find a better physics and general relativity to explain these things, you know, go ahead. You know, you can do it. But anyway, that's where I get it. Yes, sir.
Somebody mentioned to me that there was a fourth probe that was sent out, and it's they found some different finding with this regards to the CMB. Is that correct?
No.
Has there been any other probe that was sent out after the third one?
No. As a matter of fact, I don't even know of any plans to send another probe out for this specific reason.
Yeah.
The only thing I know of in store is the 2023, they expect to get the, what do they call the array telescopes up in Arizona, like 100 telescopes looking at, you know, some point in the sky and think that they can define things better. That's the only thing I know in the offing. No. No. I think they're afraid to.
Yeah.
Look, these things cost billions of dollars. And every time they send one up, they get the same results that we'll see tomorrow.
Right.
Okay? Same results. And the results are the Earth is in the center of the universe. So why would you want to do that again? You know? I mean, 3 strikes and you're out. That's what we say here in America, don't we? Oh, Mark?
I think.
Yes.
I just wanted to know when you're going to have your film of the creation available to us to buy.
That depends on my producer, how fast he can work. He's had some setbacks. And he promised that he would get it done by December, but it doesn't look that good to me. I think it's going to be next year.
Is it going to be wide release in theaters or something?
No, just DVD. I will never go the theater route again. I can tell you that. It's too much of a hassle. Yeah. Yes, Owen?
In the Big Bang cosmology, the universe expanding, the geocentrism universe, would it also be expanding, or would it be just
No.
fixed?
Now, this is an interesting comparison, because I tell them, look, your universe is expanding, accelerating in the expansion. My universe is rotating and accelerating. You know what? There's really no difference between the two. You have a moving universe, I have a moving universe, except mine's circular and yours is linear. But you know what happens in a linear expansion, linear acceleration? You got too many problems you have to fix. Like, where's my energy going to come from? And what is it expanding into?
Yes.
Where's it going? You know? I don't have to worry about that because it's all going in the same place. You see?
And also, would you say that these distances that they say, like, I think they say the universe is 93 billion light years across, would you say that's pretty much the same, but the geocentrism is much smaller? Or?
No. Here's how you look at that. The stellar parallax that we covered today, remember that? Stellar parallax? That's the only empirical method of measuring the distance to the stars that we have. Anybody. The most that will give us is about 300 to 600 light years. That's it.
Yeah, that's small
That's it.
compared to what they give.
Yeah, and they haven't even reached the 600 yet.
They talk about 6 billion light years away.
Yeah, well, see, they don't do that empirically. They do that theoretically. Theoretically, that comes from the redshift, and we're going to cover that tomorrow.
Can you read the questions?
I'm sorry, yeah. What was your question again? What was it?
Oh, the first, I asked two. The first one,
Yeah.
in the Big Bang cosmology, the universe is expanding. Is there any expansion going on in the geocentric universe? And that was the first one. He said no. The second one was the size of the universe. Big Bang cosmology says it's 93 billion light years across, and Robert just said there's only about 300 to 600. What is that? 300
No,
to
I
600
just
light
said the
years?
only empirical method of measuring it is by parallax. And parallax only gives us between 300 light years and 600 light years of distance. So that is a relatively small
For the
universe.
universe.
Okay?
Yes, yes, yes.
For the whole universe.
So
Now,
we really don't think it's even that, it might not even be anywhere close to being that big.
yeah.
93 billion.
So I take an average of 450 light years just to satisfy them. Now, that's a lot smaller than their Big Bang universe, but still. And you'll see that tomorrow in the movie, okay? And there's a scientist that was in our movie, The Principal, George Ellis, who said, you know what, after all this, the universe might be quite small. So, there you go. Again, from a secular source, probably the greatest mathematician this world has ever seen since, you know, what's that guy's name? Leibniz or calculus, Newton. Anyway, so we'll deal with that. And I think so they use redshift as the second method, but it's theoretical. It's not empirical. Okay, because we don't know. We don't know exactly what causes redshift. We're guessing that because the wavelength of the light is stretched, that means it's going to go to the red end of the spectrum. Okay, that's one possibility, but you know there's 60 other possibilities that they found. So to base distance on redshift and then claim that the universe is 93 billion light years in diameter, that's a stretch. You can't prove that. So, okay? Anybody else? In the back?
Yeah, so I just want to kind of have when you only have 30 seconds of someone's attention, you know, to kind of summarize all the pieces together. Geo versus helio, they're equivalent geometrically.
Yeah.
So that's the relative motions piece. Then on the dynamic, that's where it gets a little more interesting. They are very different there. Helio treats these forces as fictitious, and they just call them the effects, and they ignore the effects of the rotating universe. And then how do they decide, first of all, is that a pretty good way to summarize the?
Yep, it's the only way to summarize.
Okay, great. And then you mentioned like Newton, but then Einstein. How do they choose how they rely on Newton versus Einstein?
It depends on what they know.
Yeah.
Like these two guys that I've just debated, Robert Carter and Jonathan Sarfati, okay, taking on the task of trying to denounce geocentrism for creation ministries. So what they do is they avoid Einstein and they stick with Newton, but they know nothing about the inertial forces. So they're arguing against a straw man. And so you have to basically educate them to what Newton really said and how it really works. And if they disagree with you, you take them to Wikipedia, like I did today, to show them, no, this is how it works. You have to add in those inertial forces to get that probe to go to Mars. Now, they may or may not understand that, but that's where you have to start. Because if they don't get that, it's a lost cause.
Okay, would you get that? Know how to send the probes? They're relying on kind of hybrid between Newton and Einstein, or how would they answer that?
All they did in their debate was they said, and the further refinements of Einstein, period. That's all they said about Einstein. Okay, so I knew what they were doing. I knew they wanted to go to Newtonian mechanics, because see, they're basically fighting the flat earthers. The flat earthers know nothing about dynamics. And they can't, their system won't work dynamically. Okay, it just won't work. Geometrically, yeah, you can make a few arguments that seem satisfying, but dynamically it won't work. So they're attacking them, but they forget, look, there's a whole other geocentric camp out here that believes in a spherical Earth and a firmament around it and heavens and all that you have to deal with. Okay, so that's what I want to draw them to. And that's where you need to start.
Yeah, I guess we'll follow up one last time. So in other words, the actual people at NASA and JPL who do know how to do the calculations to get the things in there, they would say that they're relying on Einstein stuff, and they kind of discount these now too? Or do they think that they have a hybrid?
And, they would do both. A JPL guy and a NASA guy would do both. And I talked to one about 2 weeks ago.
Yeah.
And he says, yeah, I agree with you. I agree with you that in general relativity, the inertial forces are going to be created by a rotating universe. Okay? And he didn't know what to say about that. So I said, so you see why we don't have to make them up, call them fictitious? Because they're already there. Okay? Okay, I accept that. But he knows the flaws in Newton's system. He knows that they're fictitious forces. So he didn't go in that direction. He just argued from general relativity. And that's fine with me. Because if he does, he's never going to win the argument. All he's going to do is open up the possibility that they've been missing geocentrism for how many years now? Good? Yeah.
Are you going to tell us about the Sannyak Experiment and why you don't read about it in physics textbooks? Or is that beyond the scope?
It's just, I think it's beyond, But I was talking to two gentlemen before. We were talking about the GPS satellites. Because he asked me if there was a Michaelson-Worley experiment that we could do in space instead of on the Earth that would show the positive results of Michaelson-Worley if indeed the Earth was moving. I said, yeah, we have one in space now. It's called the GPS. Okay, so let me go there, because the GPS is based on the Sannyak experiment. Okay?
Okay.
All right. So in GPS, everybody uses it, correct? We get to our destinations, we know how it works. So the way they work is they have 3 satellites in space, and they have 1 ground station satellite. So they have a satellite in the east, they have a satellite in the west, and they have 1 triangular, so they can triangulate. Okay? And then they have a ground station. So the satellite in the east will send an electromagnetic beam to the satellite in the west. Okay? Satellite in the west will send one back to the satellite in the east. Except one of them goes faster than the other. Can you guess which one it is?
East to west.
East to west goes faster than west to east. Every day, every hour, every second. It never deviates. It's always 50 nanoseconds faster than the one going west to east. That shouldn't be. Why? Well, did Uncle Albert tell us that the speed of light is constant?
You did.
Yes. Okay, so what's going on? Well, we're not being told the truth. That's what's going on. Okay? And the way we found this out was in our movie. We had a guy in the movie, his name was Ron Hatch. He works for Navcom Technologies in California. He died 2 years ago. And Navcom contracts with John Deere Tractor. John Deere Tractor has developed tractors that will work by GPS satellites. You don't need a man in the tractor. They will go down a straight line and make your furrow for you, as long as that GPS satellite is communicating with it. And in order to make sure that those tractors went in a straight line, Ron Hatch had to go into the computer program of the GPS satellite. And that's where he found the dastardly deed, which was they pre-programmed the computer with the Sannyak effect so that the light beams will turn out to go the same speed, whether it's going east to west or west to east. Okay? And there they can come out and say, see, the speed of light is constant, never changes. But they don't tell you that they changed the computer program in order to get it that way.
Sannyak had an interferometer experiment with perpendicular beams of light spinning on a table, and his experiment found that light doesn't have a constant speed, but it varies, and that's contrary to what Einstein taught.
Yeah.
And you won't learn about it in physics textbooks because they don't like to tell you about it.
Well, they will speak about it. They'll call it the Sannyak effect. Okay, and they'll use it in ring lasers. They'll use it in many applications in physics. The Sannyak effect is a very popular topic. Okay, but explaining why it is that way is not such a popular topic, because that's when relativity starts to be undermined, because they can't really explain it.
It was 1913.
1913, Georges Sannyak, French scientist. And that was the precursor. Well, actually, you know what? I should probably mention this other experiment, because Sannyak was the precursor to another famous experiment done by the same Michaelson guy in 1925. It's called the Michaelson-Gale experiment. Now, here's an interesting experiment. Instead of trying to measure the speed of the Earth around the sun by light wave interference in an interferometer, he was going to measure the rotation of the Earth by the same method, same interferometer method. Okay? So he sets up his thing, and all he basically has to do is rearrange it so that instead of going crisscross, it now goes in a rectangle. The light beams go in a rectangle. Okay? He puts them in Illinois and spends a lot of money, and he even took all the air out of the pipes. So nobody could say that the light beam was affected by the air. Okay? So he vacuumed pipes, and what did he find? Did the same kind of principle experiment that he did in 1887, which was, I want to see how much this ether impedes this light beam. Because he still believed in ether, even though Einstein had done away with it. And what did he find? What do you think he found?
You found a 24-hour, right?
What's that?
Enough for rotation.
Yeah. What did he find? What kind of interference of the waves did he find? Did he find what he was looking for? Yes, he found what he was looking for. He found an interference of the light waves going in the direction of west to east by 98% of what was needed. 98%. Now remember, in his Michelson-Morley experiment in 1887, he couldn't even find 1/10 of what he needed. But in this experiment, to measure the rotation of the Earth, now your minds are thinking, right, Roland? Didn't you say the Earth didn't move? Okay, yeah, I did say that. But he found 98% of it was right to what his specs were, right to what he was anticipating. Okay, so now we got a problem.
That's the universe rotating around the Earth.
You took my answer away. They're very good. Yeah, okay, so, well, before we get to that, I got to show you the dilemma of Michaelson. Okay, because Michaelson said, look, I used the same interferometer machine to measure the Earth going around the sun, and I got nothing. How can that be? Look, I know the Earth's going around the sun, you know? So I don't get anything there, but when I do this, and I only had to do it one time, this experiment, to measure the rotation of the Earth, I get a 98% result, positive, that the Earth is rotating. And I'm using the same experiment that I used 25 years earlier, or how many years earlier? And it just doesn't make sense to me. Yeah, I can see why it doesn't make sense. Because the Earth ain't moving around the sun, so that's why you're going to get zero there. And the reason you're getting 90% rotation here is because what? It's not the Earth rotating, it's the universe rotating around the Earth. That's why you're getting it.
So he could explain, in his view, he would explain the day and night, he wouldn't be able to explain the seasons.
Yep. You can explain the day and night, but look, if you can't explain the seasons and the Earth going around the sun, it's worthless. Heliocentrism needs both. They need a revolution of the Earth around the sun, and they need a rotation of the Earth 24 hours. If you only have one, then your theory has been falsified. It's basically what it boils down to. Geocentrism, of the two, we only need one. And the way we explain that is the universe is going around the Earth, because the Earth is fixed. So we're going to get the same 98% that you got. And we only need one, so we've verified our theory. You see? So here's another problem with heliocentrism. They can't answer these experiments. So that's not the trick. That's the easy part. The hard part is getting them to see it and believe it and admit they made a mistake. That's the hard part. Okay, let me see. Did you have a question already?
Me?
Go ahead. We'll get you next. We'll get you next. Go
I have a
ahead.
quick question. With all this evidence of geocentrism, how much of the scientific community is starting to come over to geocentrism?
Look, they're already over.
They're already over?
They're already over, they just won't admit it.
It's like evolution. Everybody knows it's false, but they just can't talk.
Yeah, like, what's his name, from Harvard, Lewontin. He says, look, we know evolution doesn't work, but our only alternative is special creation, and we can't let a divine foot in the door. Okay, so he's already over, he just won't admit it.
James Stewart does a really good job of that, the impossibility of how evolution is supposed to work.
Yeah, you know what, we have gone down that road so many times, it doesn't work. Maybe on a few guys. So there's something deeper going on. Okay? Something deeper going on. And these guys, and I've talked to physicists of everything I'm telling you today. They go, oh, that's interesting. Yeah, I see what you're saying. Yeah. But they're not going to make a move. They're too tied up in their lifestyle. Okay? That's what it's all about. This is just a cover. And they thought that they could get away with it by talking all this scientific highfalutin equations and all this stuff until somebody came and just pulled the plug on it and showed them, come on, man, you've been fooling us for all these years. You don't know what's going on. But that's not the issue, like finding, okay? It may move them down the track just a little bit, but then there's going to be something else that pulls them back. So it's a hard issue.
Right, it's career versus science.
Yeah, I mean, who wants to give up their sheepskin on the wall? Who wants to give up a six-figure salary? Who wants to give up, travel here and there and everywhere? Yeah, I mean, come on, we're all men. Yes, sir.
You read this term, science proves there's no God, and after this section, all these scientists, they don't want to believe that what's going on, they contradict each other, they make up stuff, so that's a totally complete, saying the same is just false.
Yeah, you know what? The way science works today is you have the priesthood with the Pope.
Oh.
And they announce what everybody's going to believe. And all the lower, the priests and the parishioners of the science community all follow in lockstep, whatever they say. So all this talk about dark matter, dark energy, where did that all come from? It came from the Pope of science and all his cardinals who dictated. These guys, they work at Oxford, they work at MIT, they work at Stanford, everywhere. Okay, they all get together and they figure it out, and they're all the upper echelon guys. Okay, and all the peons down here, the 90%, they just follow whatever they're told to do, or they don't have a job. That's all there is to it. Okay, so you thought we were dogmatic in the Catholic Church?
Touche.
Yes, ma'am.
It's like they wouldn't send up another thing to see the background radiation.
Yeah.
Probably. Somebody that makes video games needs to make a miniaturized version of Michaelson and all these other things and put it in a video game that one of the capitalist, free-riding the stars guys go on and hide it in plain sight and run them up there out of Earth orbit.
You're elected.
I have one more.
Anybody else? One more?
Just one more, yeah. I'm reading a book right now, actually, by John Hartnett. I think you quoted him in your book.
Yeah.
Right? I don't know, does he work for Creation Ministries still? He might.
I don't know if he used to or still does. I don't know.
Right. Well, in one of his chapters I'm reading, he talks about gravity and its effect on time, and how supposedly with atomic clocks at sea level, they tick differently than clocks at the top of a mountain. Is that true?
Yeah, it's true.
Gravity affect
But see, they're
time?
not really changing time per se.
Yeah.
All they're changing is the mechanism of the clock, so it's going to count slower. It's easy to prove that a clock at sea level is going to go a lot slower than a clock at the top of Mount Everest, because the gravitational potential is a lot less at the top of Mount Everest, and that gravity affects the mechanism of any clock, including a cesium clock. Okay? So you can say that time is slowing down,
But it's only
not
the
really
mechanism.
time, it's just the mechanism, that's all. Okay? Now, that's where Newton had something on these guys, because Newton said time's absolute. And he's correct. Time is absolute. The problem you run into is when you start trying to measure it, then you see little cracks here and there that you can't say it's really absolute in the absolute sense. But that's another issue altogether. But at least he was on the right track there. The one he really fell off was with the absolute space thing. Okay. So, yes.
As an online question, do you believe that the universe is infinite?
No.
Question?
Yeah, and as a matter of fact, I mentioned George Ellis as the guy who said that there's a distinct possibility that we have a small universe. And the reason he says that is what he said was because we have a spatially confined universe. And if you do, it's going to be small.
And if you talk about Hildegard of Bingen tomorrow, you'll learn about the 16 megastars at the very periphery of the universe that God taught her about.
Yeah. I don't cover that exactly because there's other stuff I need to cover, and I don't have enough time to cover it all.
Now they heard it.
But they can buy the book and read all about that. Okay, anybody else? Yes, sir.
So, the recent discoveries of like the Higgs boson particle, is that complementary to the geocentrism view of the universe, or does it go either way?
He says, is the Higgs boson complementary to the geocentric universe? The answer would be no. But it is complementary to the ether hypothesis. Okay? Because that's basically what the Higgs boson is acting like. A medium for all the other particles. See, they have so many particles now, they don't know what to do with them all. They have 60 plus particles. So if you can get this other particle that sort of is like the medium for all these other particles, it makes everybody feel good. Okay? So it's theorized in that sense. But all this does is push us further into this ether concept that space is not empty. It is substantive. And we need that to make our physics work. Whether it's Newton or Einstein or the geocentrism or whoever, we all need the ether to make it work. And look, we found evidence for it, so let's stop arguing about it. The only reason they're arguing about it is because they want to save face for Einstein, because he took away the ether in special relativity. That's why. And if you say that the ether exists, well, you would just expose this facade that he's been perpetuating on us for how many years? For over 100 years. And that's, by the way, where this whole speed of light thing came from. Okay?
Last question.
In the special relativity, light speed is limited to 186,000 miles a second, whereas in general relativity, it's not limited at all. Okay? So why is it limited in special relativity? Well, one reason we found was if you limit it in special relativity, then the Earth has to what? Move. The Earth has to move. If you make the Earth motionless, then light speed has to vary. That's what that's what was in his mind. He had two choices. Okay? So this whole light speed thing was invented to keep the Earth moving. That's the impetus for it. Okay? Otherwise, if you keep the Earth motionless, as he did in general relativity, then what happens? Then the light speed has to be variable. No two ways about it. Okay. Any last question? Last question?
We're done.
Last question.
Thank you. Kind of back to that, just more like an intuitive touch point for somebody wrapping their mind around geocentrism. I might have read this from you, but the idea we can sense acceleration, like even if you're blindfolded in an airplane, you can tell what it feels like. When we feel acceleration if we're on the end of this thing that's circling around at the end of the spoke, do you feel like that's a pretty good one? Or do you have a better one? Speak to that.
I think you can answer that.
I can answer whether you have a better one?
No, you can answer why they don't feel this pressure moving to the outside.
Yeah, so in other words, I'm saying, do you feel like that is a good intuitive way for somebody to kind of get them thinking?
We may be missing each other here.
In other words, I'm just trying to say, is that a valid thing to get somebody thinking about, you know, geocentrism is true, because you actually kind of already intuitively know it, because you don't feel right now that you're really past.
It works with some people.
Some people, yeah, maybe.
I thought
Because, you see, all the speeds are calculated by God, of course, so that it would have the least effect or minimal effect. Okay, so that's what you have. That's why the Earth is as big as it is. That's why the universe is as big as it is. That's why the stars are as far away as they are. That's why the universe travels at a certain rate as it rotates. All of that has to go into the formula to figure out what's going to be the least effect on these biological specimens that have to live on this rock. Okay? How am I going to make it so that it's only 70 to 80 degrees? With the air, you know, the air pressure's just enough. It's not too great, not too small. The gravity's just right.
Hold clouds in the air.
Clouds in the air, sun's, you know, only there for a certain amount of time, so it doesn't burn us up. How are you going to calculate all that? Well, you have to have one giant equation, basically, that has to find the minimal effect on these biological specimens so that they can survive, is what you're basically doing. And that's why I tell them when I talk to my kids, I point to a rose, and I say, do you know what it took to make that rose? And they say, you know, dirt and, you know, water and all this stuff. And I go, no, it took a whole universe to make that rose. Whole universe. And if it wasn't made the way it's made, that rose would never grow. See? All right. We're done. We'll see you tomorrow.